On August 9, 2006, a high-level BP representative contacted Test Techs regarding the incident or situation in progress at the North Slope in Alaska. For the past 19 years, Test Techs had been working at various BP refining and chemical plants across North America and the UK. More specifically, conducting advanced, non-destructive examination methods for the inspection of numerous types of process plant equipment, such as boilers, heat exchangers, piping, pressure vessels, and storage tanks. Over the course of 2006, Test Techs had been working with BP on several projects, including the inspection of over 2,200 storage tanks in the northern panhandle of Texas, as well as some applied research and development projects for offshore NDT applications. These projects and R&D efforts revolved around the Test Techs' proprietary low-frequency electromagnetic technique, LFET. On August 13, 2006, Test Techs mobilized work crews to arrive at Anchorage in order to stage and prepare for arrival at the North Slope. Once on the slope, it was possible to gain a better sense of the entire project scope. It was learned that there were two lines to be tested, the East Transit Line and the West Transit Line. The East Line had a tape coating under the insulation, while the West Line was bare under the insulation. In total, there was 10 miles of line to be tested. The next step was to demonstrate the Test Techs low-frequency electromagnetic technique, LFET, to the on-site BP staff, the Department of Transportation, and various representatives of federal and state government. BP, along with the DOT, had isolated several sections of actual piping with known natural defects. While all the insulation was removed from these areas, there were both bare and tape-coated sections of piping. These sections of piping were used to validate various non-destructive examination technologies, as well as qualifying individual NDE system operators. The Test Techs LFET systems detected all of the flaws within the test areas on both the bare pipe as well as the tape-coated pipe. Other technologies, such as automated ultrasonics and especially electromagnetic acoustics, had varying levels of success in flaw detection on the taped pipe. Because of Test Techs' success on these tape sections, BP determined that LFET's best contribution initially would be on the East Line, which was taped. Any flaws found were to be marked and then proved up or verified using a separate automated ultrasonic crew. At this time, Test Techs was employing off-the-shelf LFET equipment that used 4-inch wide scanners. In other words, each pass of a scanner would cover a 4-inch wide swath. These scans were done axially or longitudinally to the pipe. The inspection consisted of 2-man operating teams. One man scanned the pipe while the other collected and analyzed the data. In this mode, each team netted an average productivity of about 100 foot of line scanned within 6 to 10 hours of actual scanning time. The area of concern was the lower sections of pipe from approximately the 4 o'clock position to the 8 o'clock position. The conditions were somewhat unpredictable, with daytime temperatures ranging from 20 to 50 degrees Fahrenheit, with numerous days of steady drizzle and or rain. There were also some days with snow. In tandem, back in Pittsburgh, the entire Test Techs production staff, as well as the R&D staff, were in the process of making a specialized LFET scanner that would scan an 8-inch swath while moving in the circumferential direction. The concept and production of these 8-inch scanners began without anyone from Test Techs having even seen the actual piping or work environment. As anticipated, these new 8-inch circumferential scanners were validated on the test sections of piping with positive results. Therefore, these custom 8-inch circumferential scanners replaced the off-the-shelf 4-inch LFET scanners. The Test Techs equipment and operator were set up in a mobile workstation shown here, while another team member moved the scanner over the actual piping. When a flaw signal appeared, the operator would communicate via radio to the scanner operator, who would then pinpoint the location for further proof-up. All data was saved for any future reference needs. Shown here is a typical set of data with no flaws found. Shown here is a set of data with flaws greater than 70% wall loss or less than 0.112 inches wall remaining. The LFET technique uses discrete send and receive coils. The send coil or driver coil is excited at a very low frequency, 10 Hz or less, which creates an AC electromagnetic field. This field propagates into the test material from one side through to the other. In areas with no wall loss, the electromagnetic field will experience a set amount of signal strength loss as shown in the top figure. When the scanner moves across an area with wall thinning, a stronger electromagnetic field is measured, as shown in the lower figure. These signals are displayed in such a way as to generate a real-time, three-dimensional color display. Meanwhile, back in Pittsburgh, the Test Tech Solutions Provider Group, along with the urgings of our BP contact, was heavily invested in developing an automated scanning rig that would scan the entire area of concern in one pass while being self-propelled. This rig became reality from design to implementation in a remarkable 21 days. It was called the LineCat. With a full-service prototype machine shop, sensor design lab, and manufacturing group, all components of the LineCat were being developed in parallel. Test Tech's entire production and R&D staff worked on the LineCat, with many working 7 days a week. A section of pipe was procured and set up to put the LineCat through a battery of performance tests prior to being shipped to the slope. The LineCat is propelled by a remotely controlled magnetic wheeled crawler. It has a contour top shell which supports and stabilizes the main sensor array. The sensor array itself is made up of 16 individual scanning pods, which contour to the actual geometry of the pipe via a flexible coupling system. The LineCat specifications include 128 sensor modules with 16 exciter packs. Circumferentially covers 32 inches per linear scan. Motorized to travel at speeds of 6, 8, or 10 feet per minute. The data is linearly encoded. Modularized for quick assembly and disassembly. Able to travel around bends. Has sufficient clearance to travel over welds. All components of the LineCat are designed to withstand conditions down to -40 degrees Fahrenheit. Upon arrival at the slope, the new rig, the LineCat, was validated on the test pipe for BP and the Department of Transportation. Here, the LineCat has traveled around a 90-degree bend, having tested an expansion loop on the west line. This is the undersection of the LineCat, containing scanning sensors spanning the 4 o'clock to 8 o'clock position of the pipe. The operator, shown here, is remotely controlling the LineCat from the mobile workstation. Due to the ever-changing terrain conditions, provisions had to be made like the use of floating platforms when over water. Here is a flaw area from the actual line showing metal loss of 30%. Comparing the techniques chosen for this inspection, electromagnetic acoustic technique, or EMAT, did not give very reliable results when it tried to test through the thin layer of tape wrap that was under the insulation on the east line. Automated ultrasonic technique, or AUT, gave good results, but the productivity was slow in comparison to the group of methods present. Low-frequency electromagnetic technique, or LFET, was the only technique that could effectively work through the tape wrapping and have the highest overall productivity. In recognition of continued excellence, Test Techs received the BP Prudhoe Bay Oil Transit Pipeline Support Award of Appreciation for non-supervised work. Future applications for the line cats include proving up data acquired from internal pigging, testing areas of pipe crossing roads or rivers, inspecting riser pipes on offshore platforms, and inspecting other pipelines worldwide. Test Techs has been serving the industrial industry for 20 years, has developed numerous innovative state-of-the-art non-destructive testing systems, tests pipes, storage tanks, boilers, etc. for the refining, petrochemical, chemical, and power industries, has 7 domestic branches, 5 foreign operations, and several licensees, and is staffed with 150 employees worldwide. For other products and services provided by Test Techs, please visit us at our website, www.testtechs-ndt.com.